This is a lecture and supplementary lecture to the Executive Black Belt class. This covers in in week 4, the visual display of quantitative information. This is slides 177 through the end, 208. And what I want to do is just kind of give you a little introduction to some of the art of displaying quantitative information in a way, not to give it marketing glitz. I'm afraid I'm not really qualified for that. But what I am qualified to do is to initiate you into some of the tricks of the trade of showing, of letting the data star in your visual displays. So let's have at it. Okay, the first thing I want to talk about is why is visual display important? And the reason is basically because we're human. We see, we feel, we hear, but mostly we see. Most of our brains, or a significant amount of it, are dedicated to processing visual information. It's part of what brought us out of the trees, our need to have stereoscopic vision. Actually, was when we were in the trees, was highly important so we wouldn't fall off branches and all sorts of things like that. I'm sorry, I'm having a little bit of a throat problem tonight, so I'm just going to use a little spray. Okay. So we're very visual animals in a general sense. Second thing is numbers are ubiquitous. They're all over the place. And if we don't learn how to display quantitative information effectively, we're going to continue to remain slaves of it. And now the unfortunate thing is that almost nobody is taught how to do this, including people of my profession, statisticians, and often we're the worst culprits. So there's a few incorrect perceptions here. First of all, the one that really gets to me is that numbers speak for themselves. They don't. Numbers always have to have a context. They are language. Mathematics is a language, just like any other language, maybe a bit more abstract. But the numbers actually always represent something in real life or in the physical world. They aren't simply valuable in and of themselves, at least in the things that we look at. Second thing, as I said, there's a common misperception that we already know how to do it, or that the designers of Microsoft or Apple or any of the places, Google's probably the best at it in terms of their displays, already know how to do this. That's simply not true. Third one is that statistical data are simply boring. I don't feel that way. And that graphics, finally, that graphics are really for the unsophisticated reader. That's not true. A good graphic can be fairly complex, and we'll run into a couple of them in here that are pretty complex. Having said that, they can still be designed well. I'll have a couple of thoughts at the end about who you might want to Google and check out and listen to some of their stuff, good and bad. Okay, let's take you through a few nightmare galleries things, and just to give you an idea, these are things that we're useful, and these are used to, and these are in some ways common outputs from a lot of software products. So this happens to be an standard output from Minitab's Pareto charts, and you can see that the data, the plot itself, is really just this tiny, tiny bit right here. This is really the data. That's it. And so of all this space, the data are really only taking up this little bit. Maybe a tiny amount of information is crammed into here with a secondary axis. I actually question whether any secondary axes are necessary or valuable. But that's for another lecture, perhaps, a deeper one on this. But the point is that very little of the data is shown. There are some numbers here. There's a table of numbers. But it almost makes it seem like if you're going to be doing that, why not just give a table? And by the way, there are times when a table can be very compelling. Let's look at another one. This is one of my favorites, one of the ubiquitous pie chart. By the way, the man who invented this is also the man who invented the bar chart and some others. William Playfair in some amazing stuff was the first to use a bar chart. Anyway, here's one of my all-time unfavorites. The exploded, first of all, it's exploded. It's tilted to give you a side angle, which really kind of lies at how much the data really represents each slice. And this can't be much worse. It's also a pie chart, which makes it very, very difficult. One of the difficulties of pie charts is that even a regular pie chart, we have a hard time understanding how much angles contribute to a total, and to be able to compare the sizes of angles. Our brain just simply doesn't do that very well. The second thing is this one really taxes our short-term memory, because if we really want to know what blue is, for example, we have to look over to here and see that it's retail. And then if we want to see something else, we have to look at this and then back again. I guess this is other. And then purple, and there we go, manufacturing. And by the time I do a few of those, I forget. So when I'm looking at the pie chart, it's really hard for me to even remember which are the biggest slices. Sure, I can tell the difference between this 3% and the 8%. Oh, and by the way, it's easier since I have the numbers there. But if I have the numbers there, why not just use the numbers? All right, anyway. Hopefully, through the reading that we've looked at, you should have convinced yourself that very few situations are good for is a pie chart better than other charts. Okay. By the way, I've heard a lot of people say it really matters on the context and so forth. No, it really doesn't. If you're doing a marketing presentation and everybody understands pies and you just want to show a chart, fine. But if you want people to read and understand the data and make real comparisons, then don't do that. We'll find that you use a bar chart instead. Here's another one. This is also a Minitab output. I do like Minitab, but Minitab likes to cram lots of things in, and in a not too elegant way. Here there's a bunch of statistics really put in there. Here's a box plot. Here's some confidence intervals, which, by the way, are also given over here. Here's a normal fit to the data. It's all kind of crammed in there. And what's interesting here is that also there's a normal fit, there's a bell curve fit to this, but the data are not normal very clearly. So what is that all about? Here's another one. This is one of Minitab's capability outputs using very similar or the same data. You can see that there's just a lot of stuff that's in here. Could be useful perhaps, but again, if you're going to just make the display and want people to be looking at the display, it's the display that should be the star, and the number should be the star of the display. Here they're not. We have a big amount of gray, and only a small amount is the plot itself. Okay, here's an interesting one. For this one, there's been some work putting together a time series. It looks like it's a control chart, but we've got all these other lines, and it's just very distracting. There's lots of what Edward Tufte would call chart junk. By the way, Edward Tufte is sort of the granddaddy of all the commentary on these things. To go against Edward Tufte it's almost a sacrilege. I actually don't agree with Edward Tufte on all the things. I do think there's some good places for very high quality, sometimes even misleading marketing glitz charts. That's fine if they're done well, and then they can be remembered, and the figures can be remembered from them. And but in general, Tufte's pretty amazing. Here's another one right here. This one happens to show, this happens to be a bar chart that shows a time evolution. The main problem with this is the wrong chart. We'll find that when we want to show time, line plots with connected dots are much better than that. So this chart actually has that going for it, but it's got all this other distraction. This particular chart doesn't. It's also got two pieces of data when really you only need one. You could look at the difference, or you could look at a trend line or something like that. That would greatly improve this chart. Okay, this one happens to be a table, and although you might say, boy, I haven't seen too many tables that are this bad. This is pretty bad. I would agree with you. Most people don't do this, but this is by no means the worst chart I've seen. All sorts of stuff wrong with this. First of all, just so many digits that it's really hard to see. Very heavy lines on the grid, and the dark colors are certainly not helping. There's also no order to the data. I guess there is some order because this is January through June, so there's some order here. Here's an attempt at this chart to actually show numbers that are in there. Really hard to look at. We have a very high contrast colors. High contrast colors saturate the eye very quickly. So if you want to use, if you want to get people to focus on an area and to stare at it for a long time, you'd use a lower contrast color or some sort of other thing that can make something pop out, like a highlight or a different font or something like that. There's plenty of rules that go along with this. Again, I don't claim to be telling you everything here, but clearly it's hard to look at this chart for very long. One of the reasons is we have this really bright yellow. Think about that with your when you use default colors in Excel and you're using red, yellow, green. If you want actually people to look at the chart and to look at your displays and to look at it for some time and to analyze, you will do better to use low contrast, red, green, and yellow, than high contrast. Oh my goodness. This one happens to be, this was a big thing a few years back. People were using lots of bubble charts. I don't even know what this shows. This is supposed to be showing risk by vendor tier for IT spend. Size of the bubble is supposed to be the IT spend. The vendor risk is the y-axis, and the criticality is the x-axis. It just doesn't even make sense for the chart here. We'll come across, this is admittedly a difficult one because we have 3 dimensions, so it's difficult to make a good chart. But what I can tell you is this one did not achieve that. And if you don't believe me, stare at this for a while and see what it's really telling you. This is an attempt to improve upon it a little bit, where here we have the IT spend, here we have the business criticality, and here we have the risk, vendor tier, whatever that is, and we have little box plots for each one. They're just so hard to read, largely because they're mostly outliers. That probably means that the data are so skewed, they're problematic. Okay, so what are a few rules of thumb that we can use when applying not chart logic, but when making better charts? Let's talk about that, and then we'll talk a little bit about Minitab, Excel, PowerPoint, and give you some examples. Okay, so here are some rules from Tufte, and as I said before, Edward Tufte, you can look it up. He wrote an excellent book called The Visual Display of Quantitative Information. He's written several he's written several books after that. I think that's the one that you really want to read. So you can take it out of the library because it's an expensive sort of art coffee table book. But it is pretty easy to read also. The Visual Display of Quantitative Information, excellent book. All right, so here are some rules from Tufte. Number 1, above all else, show the data. Okay, so it's sort of a thou, this is thou shalt. It's interesting that there are 10 little bullets here. I should have thought of that before. Second is maximize the data to ink ratio within reason. So if, like an example like this, here's an example of something that has a lot of ink, but boy, it's really hard to understand the data. That's a good example of that. Another one that's got a lot here is this one right here. This has got a lot of ink, but not as much data. Or it's also got a lot of stuff taking up the data. For example, it's got this label over here. That's not data, but it's taking up space. It's got the colors here. The lines are very hard to read. There's a lot of ink in there. So try and maximize that. We'll give you some examples of that. Eliminate chart junk. That's stuff that's on the chart that really doesn't add to the understanding. Maximize the data density. It's very similar to maximize the ink ratio, data to ink ratio. Use small multiples. We'll give you an example of that. And revise and edit. Don't be afraid to try something. If it doesn't work, try something else. a few other things that I can tell you that I have found are huge in terms of the communication. Number one, above all, you really, just the general thing is, do your best to avoid all this fancy stuff that everybody puts on nowadays. Bubbles, shading, shadow, 3D effects, all detract from the data themselves and make it harder, not easier, for people to look at. Let's take a look at some of them. Grid lines is something that a lot of people like to use. If you do use grid lines, try to make them light. We'll give you an example of that. All right, so here are some before and afters of our nightmare gallery. If we really want to give the chart, here's an example of the chart. Now we're not fitting a normal distribution because the data are not normal. We're just showing a process capability. There's our line. And here the data are starting to star. Again, I don't claim that these are perfect, but they're certainly much improved. Much easier to look at this and understand what's going on than this. Here's a good example of one that maximizes data ink and eliminates chart junk. So this happens to be a time series. Here we've got a legend as well as a title, simply not needed. We've got a lot of tick marks. We've got gray color. We've got very heavy lines. So here's what it looks like on the bottom with all that stuff eliminated. Again, much easier to see any patterns. We could add a trend line in here now, and it would make some sense. We've also eliminated a lot of the tick marks on the scale and eliminated the chart. You can see that if we made this chart pretty small, you could still basically get what was going on out of it. And I'll actually show you how to do that. Here's another example. Here's our friend the Pareto. One of the things that Tufte and others have found is that people don't read so well sideways or upside down. There's a few things that we've tried to change on here. One is to simply raise this area up to make it easier to compare the size of the bars. Let's take a look at this. I mean, if we go from left to right, that's a little bit better, but still, here what we've done, you see, is instead of having that very long market sector of business, now I've just put sector so that it raises that chart all the way across, so I get a little bit more. It's still, if you look at it, that's a very small amount of area for that chart. On the bottom, this is a much smaller chart, and yet it's much easier to compare all these. What would make this chart even better is that the labeling is not so good. See how it's really hard to read sideways with your head turned sideways? What would make it better is if we were able to label this so that you could more naturally read it. We'll give an example of that a little bit later. All right, here is, and in fact, this is the example. But in this case, we start with the pie chart. Look how much easier it is to compare the groups and to notice that finance and energy basically are the two biggest ones in the chart below, which is a bar chart. So much easier to read, even without all the doodads of saying here's what the percent is, which we could add to this chart if we wanted to. Much easier. By the way, a Pareto like this, nobody makes a Pareto like this, but it's much easier to read because look at how much easier it is to read those labels. Yeah, it's so much harder to read it with your head turned sideways. Okay, so here's an example of, I said use small multiples, but really what I'd like to put is that if you have comparisons, it's very helpful to have them put side by side and to use the same scales. So small multiples means the same sort of charts. Some people think that that's kind of boring to use the same sort of chart over and over. In fact, it helps us make the comparisons that we need to make and helps us familiarize with things, what certain displays are, so we can see things more quickly. For example, it's well known that Seattle is an extremely rainy city, except that if we want to compare it, it's actually much more comparable. If you look at the plots right here, it's easy to see at a glance that Seattle, in terms of monthly rainfall, is much more comparable to San Francisco than it is to Mobile, Alabama. and in fact it has a bit of a dry season through the summer months in a comparative sense. The common scales make it easy to look at that. Plots tell those sorts of things in ways that that lore and data and numbers can't. I'll take a little more of the throat spray here. Sorry about that. Get back. Okay. Now let me give you some examples of some of the other ones, of the real nightmare ones that we did. Adoption of online referrals. Here's a few that we worked with, starting with the upper ones. And these were actually real for clients. And so we wanted to make them more compelling in some cases. We succeeded to some degree, but we also had an audience and a customer. So we had to be a little bit careful with that. Here's what we came up with. We put an equality line for 50-50, and we wanted to show essentially the percent of online referrals. By looking at this, you can clearly see that that the online referrals is increasing over time in a way that's very, very difficult to get out. You can certainly see it eventually in the top one if you really look at back and forth. But why have two things going on there when you only need one? Okay. We've also removed a lot of chart junk. As you can see, the border, the legend is now more helpful, much easier to read the dates and the percentages and so forth. Again, not perfect, but certainly an improvement. This was one of my favorites. Now, with all due fairness to the client who originally came with this, they didn't come with this number. This was sort of a first cut suggestion from somebody. Let's improve this. Now, this is what eventually we ended up with. This is in no way a perfect one. One of the things I didn't like was that we had to stretch it to get on here. However, if you look at this and you understand what's going on, we've got three things. Remember, this was a three-dimensional thing. Here we've got a grid that shows on the left-hand side the type of spend that it was, whether it was strategic, basic. There's a few things that are moved because of my little box here. That's just a PowerPoint box. Critical, important, or basic. So on the left hand we have business criticality. You know, let me actually take this out. I don't need that label there, so we can actually read the whole thing. That's a little bit better. Okay. The point is, however, and then essentially what we've got is the risk going from unknown to high. Very red hot is high, and you can see that there are some things that pop out. For example, there are some high spends that are strategic, and they're fairly high risk. It kind of makes sense. But then look at this. Here are some that are actually unknown. It's unknown what's being spent. It's unknown why we're doing it, and that's pretty high, and it's identified as pretty high risk by the project team. That's something we definitely need to look into. There's a lot of tricks that were pulled here in order to jitter, to see so many of the points. You can see that there's so many. The density of points is very high down here, and it's lower up here. There's also something that we did. We did some ranking to sort of equalize this instead of having an extremely skewed scale. In any event, all the data are here, and you can see where the density of the data is and where some of the highest risk areas are. Certainly a big improvement. Here's an example of a table that was improved. So here was the original down to the penny precision. So we removed some of that. We got rid of a lot of the dark outlines and made it a much more readable font. And see what you think. So here's what we came up with. Here's something that's a little bit easier to read. We've got the highlights with some grayscale and some bold. We've also got some other things that are put in there. For example, that's noted. And you'll see that the things are not highlighted, are simply lighter font. We're not using any grid lines, and we've reduced the down to the penny precision by we only eliminated the penny precision. We could have, maybe even to make it more readable, we could have made it in thousands. That would have been an option, although we had some that were less than that. Okay. One last example, which would be of creating a dense dashboard. And one of the problems with creating a dashboard is that one of the challenges, if anybody has ever made a dashboard, a visual dashboard with plots, is that it's difficult to get so many things on a page. There are some tricks to doing that, and happily some of the tricks are to simply eliminate a lot of the chart junk. Look what happens when you try and make a junky chart, a chart filled with lots of junk, into a small chart. You really can't even see the data anymore. You certainly can't read the dates. One of the things I've done here is I've taken out the, if you look at this, I've taken out the, first of all, I've eliminated a lot of the tick marks. I've taken out the color of the grid, and I've really lightened up the grid lines. You see that? Really lightened up. So that, look at how much smaller this chart is compared to this, and yet you can clearly see the data in a much more clear way. And then also, then I made it much smaller, and again, even at this size, which is smaller than the one up there, the virtually impossible one to read, this one's even smaller, and yet it's still legible, which is pretty amazing. You can probably improve on this by maybe making the line even a little bit more bold, and the same with the goal line up there. But you could read this. If this were sales data, you could certainly see that sales is increasing throughout the year. If it were some other data, you could certainly see that this is increasing. And here's what it looks like. Now here I've used high contrast red, yellow, green, which is kind of a no-no. If I were to redo this today, I'd certainly use lower contrast red, yellow, green. Clients tended to like this, so I went with this. I couldn't convince them otherwise. However, having said that, it's great. You look at it once, maybe the high contrast is fine, but if you want people to stare at it for a long time, those high contrast colors do saturate. This is anyway. This is just an example of what a dashboard might look like. Obviously, this is fake data put in here, but you can see I've put in 12 charts. I'm sorry, 16 charts, and it fits on a PowerPoint page. They're all readable. You can easily make comparisons across a business. This happens to be for a balanced scorecard: financial, customer, internal process, and organization metrics for each. Okay, so let me now show you, before we finish up here, I'll just give you this quote from Edward Tufte. We'll talk about that at the end, but I just want to show you very quickly in Excel how you can handle some of these things in a very quick manner. Let's just let me show you how easy it is to simply change the pie chart. I guess I've already done this. Essentially, this is the only difference is I've already done this one. I'll tell you what. Let's take a quick look at this. So if I have something that looks like this, and I've got a pie chart, I'll do my old exploded 3D pie. There it is. That looks pretty good. That looks about like what we had, right? That's Excel's basic one. Okay. And if we do a bar chart, Excel's bar chart, there's the finish. This is a little bit better, except look, we're taking up a lot of room for this percent market, so let's get rid of that. Already starting to get a little bit better. We also have all this gray in here. Let's get rid of that. Okay, and let's get rid of the bars. And voila, it's already starting to look really good. I also tend to like to fix the scale, I'm sorry, the font. Make a bold font, and don't auto scale it. I don't like the auto scaling. Again, starting to get better. And one kicker in here is I like to make the bars a little bit bigger. Yeah, there it is right there. You can actually remove the gap width and make them bigger. Look at that. That's a little nicer. Even if we get rid of percent market, everybody can see that. Let's add on the data labels. I'll put on value there. Now we can see those values if we wanted to do that. I'm not sure I like having the values on there, but we can certainly do it. And look at that. Maximize that bad boy. And we've got a heck of a chart. It's actually pretty easy to read and compare. I don't really need the labels. I'm going to take those labels off. But it's pretty easy to read. And since we've taken the auto scaling off, look what happens when we make it small. We need to have enough to do it, but we can make this chart pretty darn small, and it still is pretty readable. Look at that. Not too shabby. Not too shabby. Okay. And in fact, if you want to change the order, you could do your own poor person's Pareto chart simply by sorting the data. Let's take a look at another one. Here's one of my favorites of sort of bad ways of doing it. Here's our favorite online referral one. And I'm going to use Excel's normal chart. Here's what a lot of people would simply do. They would simply make a bar chart of this. Column chart. Something like this is just really hard to really get the patterns in this, the trends and patterns. This is Excel's default chart. So what I'm going to do is we're going to improve on this slowly but surely. First of all, the most important thing perhaps is to choose the right chart. So we're going to choose a line chart. It's very similar to a control chart, right? There we go. Okay, so it's starting to look better. As we said, we don't need this. There's only one thing on the legend, and it's also on the top, so I'll get rid of that. Wow, if that were more, the data are starting to show. Okay, third thing is let's take out some of these grid lines. That's just so many, so we can change on the scale, we can make the major unit instead of 1, we can make it 2 or 0.25 even. There we go. Again, we're starting to see things a little bit more clearly. We'll do the same thing with months, maybe make the scale every 2 months or something like that, or every 3. How about quarters? Why not? Look at that. Starting to get a little bit better, easier to read. Let's now get rid of our color. Don't need that. And our grid lines, instead of clearing them, let's just make them lighter. That ought to do it. Could put dashed if we want to, but let's just leave it that way. All right. And finally, the piece de resistance. I can move this all the way up now and put this in there. Look at that. And we're almost there. Let's change the auto scale out of this. Oops. It's in the font. We'll take off the auto scale. We'll take off the auto scale on that. I guess I'm going to make it bold, and we'll make it 10-point font. Bold and 10-point, and I'll do the same with this. Bold and 10-point. No auto scale. Okay, there we go. Almost ready. I like to make my dots a little bit bolder, and I like them to be round. That's just personal preference. And then I like the weight on my lines to be a bit bigger. And we're starting to see some good stuff here. There we go. All right, now notice that when I make it small, it still is sort of holding up its integrity. I probably have to lighten up some of these things and make them a little bit smaller, maybe 8-point font or something like that. And we'll be able to make sort of postage stamp size change the weight just one less. There we go. All right, I'm getting close, I think. All right, and we'll make this, we'll put it back down to 5. There we go. Ready? See how far we can get. Well, it's not perfect. To get this even better, what I might do is I might change this so that I can fit all of these on. Still going to keep trying. Let me try this every 6 months. All right, so that might buy me a little bit. Notice how doing this is every little bit helps. Last thing, I'm going to take the side out of it. Now there's no border. And boy, look at that. If I make the background white, I could stick this pretty much anywhere I want. Look how small that is. I can probably even make it a little bit smaller if I wanted to. But online referrals, I can take that out and write it underneath it or something like that. And that would help me. I can write that right underneath here. And there we go. I'm starting to get, or I could put it above, whatever makes most sense for your design. And there we go. We've got a nice small plot that would fit on just about any dashboard, and still is taking up, you know, the data is really the star here. Maybe at this point I'd even take out the dots, and we can start to see, you know, the trends. In fact, at this point the grid lines are really getting in the way, so let's just kind of take them out, and voila, look at that. We can make them pretty small. All right. Anyway, at this point we're really taxing all of my abilities as well, but that's pretty small, and you can see it, what a huge difference it is from what we started with, which was essentially this. Bam. And I would claim that even at, you know, something like this, we're still seeing the trends better than we are in this, certainly than in the original column chart. Okay. I want to leave you with a parting thought, and that is Edward Tufte, visual representations of evidence should be governed by principles of reasoning about quantitative evidence. Right. Not about artistic judgment and all that sort of thing. For information displays, design reasoning must correspond to scientific reasoning. Clear and precise seeing becomes as one with clear and precise thinking. So that's the whole point, is that we want the design of the graphics to be able to stimulate and distill thought. That way we can add in complicated things, let people draw their own conclusions, and so forth. If you do want to know more about this, we'll be covering a little bit more throughout the course, but this, again, remember, this is just a primer or primer. Edward Tufte, Visual Display of Quantitative Information, that is the big daddy, real landmark. Stephen Few, Show Me the Numbers, and another one of his that I really like, which is, oh, I'm looking up on my bookshelf and not finding it. Now You See It. It's called Now You See It. I did this talk before he published that, so didn't make it into this. And finally, from a more statistical point of view, Bill Cleveland did a great piece of work called Visualizing Data that really goes in and gives you systematically which plots you'd use in each different NumCat situation. So really pretty cool stuff. All right. Hope you enjoyed this and hope you learned something, and look forward to your comments. Take care.